Assalamu alaikum. The next chapter is diode and application. In this chapter, we read all these key terms. First point is diode operation. Diode consists of p-type and n-type semiconductor. P-type is called anode, n-type is called cathode. So there, these are this symbolic representation of diode. The next point is typical diode packages or surface mount diode packages. These point tells us about several type of diodes. We are study the working of a diode. First, forward bias diode. There we see that when diode is connected to external battery, V base means external base voltage. So the positive terminal of the battery is connected to the P region, and negative terminal of the battery is connected to the N region. So the diode is in forward bias. The base voltage must be greater than the depression or barrier potential. So current will be may flow between the P region to the N region. Otherwise, the current do not flow and do not cross the barrier. This is a small resistance. Our diode is connected through a resistance. It must be connected it in a circuit. Next, the P region is full of holes and N region is full of electrons. So our P region is majority charge carrier is holes and N region is majority charge carrier is electrons. In forward bias, what happen? The N region is connected to the negative terminal of the battery. So from negative terminal, the more electron is enter to the N regions and they cross the depression region and enter into the P region, and more hole cross the P regions, enter into the N region, and a current flow through the diode. All these things is happened in this forward bias, and it mentioned in this paragraphs. So the next point is the effect of bias, forward bias on the depression region. Normal condition or equilibrium state, the depression region is more, while in forward bias it becomes more thin or negligible. So in forward bias, the more and more current flow through the diode. And effect of barrier potential during the forward bias. In this paragraph, they can mention about the barrier potential voltage. The base voltage must be greater than the barrier potential voltage, otherwise current do not flow. That I mentioned you. Potential barrier voltage smaller than base voltage inversely. So come to the point. Next point is reverse bias. In reverse bias, the diode is connected opposite. P region is connected to the negative terminal and N region is connected to the positive terminal. What happened when we connect these opposite direction of the diode? The depression region is greater and greater and more widely, and it open as a switch. off switch. Let's see what happened in the diode. This is when n region is connected to the positive terminal, the electron flow through the positive terminal, and hole is p region is connected to a negative terminal, the hole is moved to the negative terminal of the battery, and more electron gathered at the depletion regions. Same and holes are gathered there at depletion region, which increase the depletion region from its equilibrium position. And we apply mostly diode to the DC voltage. There are, in this way, forward bias, the diode do not flow the current. It act as a switch, off switch, that we off the switch of the button. But at a high voltage, which breaks the diode and depletion regions, and current flow through the diode. We read it in next sections. Next, reverse current. This show that what happened when the current is reversed. In reverse current, there is very small amount of current flow through the diode, nearly very small, as electron flow through the depletion regions and reach to the positive terminal to the battery. Next point is reverse bias, reverse breakdown. When high voltage applied to the diode, the current flow through the diode by breaking the depletion regions. At limited position, if we control the current, the diode is not permanently damaged. Otherwise, if we apply a high enough voltage, the diode is completely damaged. While only some diode can be working at reverse bias directions, we study in further topics. And if we limited the current or control the current at reverse bias, we can control its damaging point. And this point is also called the avalanche effects. Next point is voltage current characteristics of diode. In this topic, what happened? The graph of a VI curve, I mentioned you in the curve. First, we see the circuit diagram. This is VF, forward bias voltage, IF, forward bias current, V base, yeah, base voltage which cross the battery. So what happened in the graph diagram? We make a graph between current and voltage. First, we increase the voltage and gradually from point A to B increasing. No current will be flow through the diode in forward bias. only a small amount, nearly equal to 0. You can see it. When we reach 0.7 volt, the current will be very fastly moving from this point to C and move on. What happened at point 0.7? What is this point 0.7? I told you. Point 0.7 is basically the depression region voltage. I mentioned you in forward bias topic that the V base voltage must be more than depression region voltage, and 0.7 is the depression region's voltage of diode. When voltage reach to the 0.7, then the depression region can be removed and the current will be flow through frequently and very fast. This circuit diagram also tells us same thing. Vf is the voltage of diode, you see it, and we connect this voltmeter with parallel to the diode. So when we increase the voltage of V base, only a very small very small number of amount of current can pass through the circuit. When we increase the V base and it Vf reaches to 0.7 or more than zero point 0.7, a current very fast frequently flow through the circuit. You can see it. One more point is this dynamic resistance, small r prime d. This is the dynamic resistance. What is this? The dynamic resistance is smaller as the current flow through the circuit more and more, and higher at smaller values. What happened? Why the dynamic resistance is here? Because the curve do not move in straight forward like that. It do not move straight while it is curve curving moving. So the dynamic resistance is in the diode, and it can decrease the voltage somehow, and this is also mentioned there. Now the reverse bias characteristics. What happen when we reverse the current? Only small amount of we apply a reverse current connected to the diode. When diode is connected to the reverse bias, a small current is passes through the diode. Small, very small, negligible. And this is the breakdown voltage. This is the breakdown voltage. When voltage is high enough and reaches at that point, the current will be flow through very fast, which can be damage the diode. Now the complete VI characteristics of the curve of diode. It mentioned here 0.7, same as I mentioned you all above. There is a temperature effects. Here we see that the 2 millimeter volt increases as the degree temperature increases. Difference between these temperatures. Diode models. Okay. Okay. The base connection. This circuit diagram shows that the diode in forward bias is connected to the battery. There is a reverse bias is connected to the battery. Battery is shown symbolically represented by this, and V base is also, I tell you, forward bias. As you know, this is mentioned, diagram A is a forward bias diagram and B is a reverse bias. So Vf is flow through this diode, while there V If sorry If is flow through the diode, and there the I is equal to 0. This represent us that If is forward current, and I represent there is 0 because the diode is in reverse bias, so no current flow through the circuit. This mention all these things. Okay, there is a diode approximations. Ideal model, we remove any external factors. So when we apply the voltage, the current is flow through the circuit without any resistance. Or this is the ideal model graph, that we apply the voltage and current flow through the circuit very fast. On the other hand, when in forward bias, on the other hand, in reverse bias, no current flow through the circuit as open circuit. As we increase the voltage, we are reverse bias, no current can be flow through the circuit. This is the ideal mode. And what happened? This is Vf for diode voltage, forward bias voltage, and If is a forward bias current. This show also this. Then in ideal model, by applying the Ohm law, we know that V is equal to IR and If is equal to V base over R limited. R limited क्या है? What is R limited? R limited is a small R. This is capital R, which apply in the circuits. So I is equal to V over R. IR in reverse current, voltage is completely current is completely 0. So VR is the voltage of resistance is equal to the voltage of V base. In practical model, the voltage source Vf. This is our diode, practical diode. This is a shaded diagram. What happened? Vf is a potential barrier. What is Vf? Vf usually we use 0.7 volt. As we apply a voltage to the diode, and this battery show that our source voltage show that we reaches to the 0.7. When we reach to the 0.7, then we can pass through the circuit. Otherwise, we do not pass it. It is as like that a battery, because when a high voltage applied to the or more than 0.7 voltage applied to the this, then it can move it, because Vf is equal to 0.7, as you know. So the current can pass through the circuit, and in reverse bias it act as an open circuit. and this is his characteristics. We reach to the 0.7 volt and then we can move upward. Next, I mentioned you Vf is equal to 0.7 volt, and by applying the Kirchhoff rule, what happened? V base, we start from V base, positive terminal, this is also positive, so VR, basically these are the resistance of VR. VR and VF. V base minus VR minus Vf is equal to 0 if we apply the Kirchhoff rule. V base minus Vf or VR. Then we know that we are limited as VR limited equal to IF and R limited. What is IF? This is IF is current, forward bias current, and R limited is the resistance. So from if we put these values into there, and we can find IF is equal to V base minus VF over R limited easily if you know the mathematics. Okay, now the reverse bias. As IR is equal to 0, so VR is completely V base. There is no exception. We do not use the breakdown voltage in this case. The complete diode model. Okay, in this model we can use the dynamic resistance, large internal reverse resistance, or small r prime capital R, and capital R for internal resistance, and D for dynamic resistance. So when we apply the voltage, again VB is 0.7, VB is 0.7 volt, and very small amount of resistance, so the current pass through the circuit. When a voltage increase, there we see that when we apply a voltage from 0 to 0.7, it reaches 0.7, but the curve is slightly down because of this R. It is very slightly down, and because of this R, in reverse bias it shows that very small amount. Sorry. Okay, so this will be happening in very small resistance. We do not use their breakdown voltage, only we use a reverse current or reverse voltage, small amount, not reaches to the breakdown voltage. Okay, next, what happened? Okay, as we know that Vf is equal to 0.5, 0. Okay, there we are now completely add it. Vf is equal to this one and this one, and show there Vf is equal to 0.7 volt IF or prime D. IF is a current, forward current, and prime D. There we can find these value we can put into the upper equation of this one. If I say this is the equation 1, then from equation 1 we get it. Okay, next is numerical. We discussed the numerical in another topics. And what is next? Half wave rectification. Okay, there is our diode working condition is completed. Thank you.